In the first part of the section, we talked about elements and compounds and the fact that elements and compounds are pure substances. Pure substances meaning that a sample of matter has a definite chemical and physical set of properties. So elements and compounds are pure substances because every particle in them is identical. In the element, it is the atoms that are identical, and in a compound, it is the molecules that are all the same. That's different than a mixture. A mixture is a combination of two or more substances that are not chemically combined. So whether you are putting together elements or you are putting together elements and compounds, if they don't react with each other to form a new substance, then what you have is a mixture. So mixtures can be different from each other even. If we take a look at what mixtures are like, we can identify them based on how thoroughly they are mixed together. So our major classification then for mixtures are heterogeneous mixtures and homogeneous mixtures. So we say they are heterogeneous if the substances aren't mixed uniformly and they're not evenly distributed. I think it is easy to identify a heterogeneous mixture in general because usually you can see the different parts that are in them. Chex Mix is a great example of a heterogeneous mixture. When you look at it, you can see the different cereals that are in there and the nuts and the pretzels. A great example would be just looking at your laundry, right? You have some red shirts and you have some black shirts and you have maybe some white socks and some black socks. It's easy to identify the different things that are in that mixture. Homogeneous mixtures are those substances that are evenly distributed, and so the mixture looks the same throughout. Homogeneous mixtures are usually hard to tell apart from those pure substances because when you look at it, it's very, very difficult to tell that there are different things in it. I guess an example of that would be like when you make Kool-Aid. If you've ever made Kool-Aid, you know that you put the little packet of flavoring and coloring in the water along with the sugar, and you stir it all together. And when you take a look at it, all of the coloring and the sugar and the flavoring has dissolved to the point where it is one uniform mixture, and you can no longer see the sugar or the flavoring separately. It's all evenly distributed. So that is an example of a homogeneous mixture. Homogeneous mixtures are also called solutions. It's easy to come up with examples of liquid solutions like Kool-Aid, Gatorade, salt water. Those would be examples of solutions. What's harder to come up with are examples of solutions that are not liquid-based, but there are plenty of those examples as well. For example, an alloy of a metal is considered a solution. What happens when you make an alloy is you mix together and melt together different metals, and when it cools, they have blended together nice and evenly. It's very, very difficult to see that there are different metals in them, but they haven't chemically reacted, so they still are a mixture. The brass instruments that you see in a band are actually solutions or mixtures of metals. So is the gold jewelry that you purchase. Gold is a very soft metal, and to make it better for jewelry, they actually mix it together with silver and sometimes some zinc to make it a little bit harder so that it doesn't bend so much. Really, what we see, though, looks like pure gold, even though it is not. So another example then of a homogeneous mixture. When we put things together, especially if we put our liquids together, we use the terms miscible and immiscible. So when you put them together, if they do mix together, we say they are miscible. So for example, if I add milk and water together, they blend together evenly, we would say that milk and water are miscible substances. When you put things together that do not mix, then you have things that are immiscible. Oil and water that do not mix together, they are considered to be immiscible. Remember that it isn't just liquids. We are also talking about gases, solids, other things that can be parts of mixtures as well. A good example of that is the pop that we like to drink. We can even have gases mixed in with our liquids. If we focus on our heterogeneous mixtures, we have specific names for a couple of different types of heterogeneous mixtures. So if it is a heterogeneous mixture, it may be a suspension. In a suspension, it's a mixture in which the particles are large, so they don't stay mixed together. Rather, they tend to settle out. If you think about orange juice that has the pulp in it, if you don't shake it before you drink it, you may have noticed that there is a layer of pulp in the bottom of the jar. So that's an example of a suspension. Ketchup is like that too. We don't see a big layer at the top, but if you've ever noticed, if you forget to shake the ketchup before you use it, usually there is a little layer of water and vinegar at the top of the ketchup, which means that it has separated. So that's another example of a suspension. Anything that you can think of that says shake well before you eat it or drink it, whatever the case might be, those are suspensions. Things like the medicine that you may have taken when you were a kid, or lemonade that has pulp in it. Salad dressings, we usually shake those before we use them as well. So those are all suspensions. Another type of heterogeneous mixture is a colloid. These are a little bit harder to identify because the mixtures are pretty small. In fact, they're small enough that they don't separate. So we may be able to see them, making it a heterogeneous mixture, but they won't necessarily be very evenly mixed. And because they won't separate, they are not suspensions, they are colloids. Jello is a good example of a colloid. We actually have the liquid of the Jello suspended in the solid gelatin, and that's what makes it jiggly. Whipped cream is another colloid. We have the cream, and suspended in the cream is the air. And so because it stays suspended like that, we have a colloid. You can just see some different examples in this picture of different mixtures. When you take a look at her shirt, even though it looks very, very even, if you look at it under a microscope, you can see they are demonstrating that there are cotton fibers and polyester fibers. And if you look at it with that microscope, you can see those differences, making it a heterogeneous mixture. If you look at the bottle that is on the right-hand side, that is supposed to be vinegar. Vinegar is acetic acid, which has mixed with water. And when you look at it, you can see it's pretty evenly distributed. It's very difficult to tell there are smaller things in it, so that's a homogeneous mixture. The salad that she has on her plate, heterogeneous. If she doesn't like the tomatoes or the cucumbers, she could easily pick those off. And the water in the glass, if it's pure water, not out of the tap, because then it would have some stuff dissolved in it. But if it's pure water, it is then a pure substance because all of the particles would be identical. This is to just give you an idea of miscible and immiscible liquids. If you take a look at the one on the left, toluene, which is used as a solvent, when it mixes with water, only temporarily mixes. It doesn't stay mixed, so we say it is immiscible. But ethanol will mix together with the water, so we say that it is miscible.